definition of resultant vector, it is a single vector having the same effect as two or more vectors, or you can substitute the word vector for any physical quantity that is a vector. So for example, if they ask for the definition of resultant force, you'll say a single force having the same effect as two or more forces. Or if they ask for acceleration, a single acceleration having the same effect as two or more accelerations, etc. Okay, so that word vector you can substitute with any physical quantity that is a vector. Now for this, there are generally they'll give you a diagram, they'll ask you to determine the resultant vector of the vectors in the diagram. Usually you'll be given a Cartesian plane, sometimes you won't, then you can draw it in yourself if it makes it a bit easier. Now in order to do this, what we're actually trying to do is figure out what would A, the magnitude, and B, the direction of one vector be in order for that one vector to have the same effect as this 10 Newton, 4 Newton, and 6 Newton forces all going off at different angles. Okay, so we're looking for magnitude and we're looking for direction of a single resultant vector. Now in order to do this, the idea is we're going to take each one of our vectors, so let's just focus on this red one for now, determine its x and y component, and when we've got the overall x component and the overall y component, we can determine the overall vector. Now the first thing you need to do always, I'm going to try and fit all of this in by writing steps and then doing steps. Okay, so step 1, you need to make all angles acute. Okay, so we don't deal with obtuse or reflex angles here. I want only acute angles. So if we look 20 degrees, that's fine. 10 degrees, that's fine. This 210 degrees, however, is not fine. So we need to make that an acute angle. Now it's up to you if you want to determine it off the y-axis here or off the x-axis. I'm going to do it off the x-axis. Now we know that from there all the way to there is 210, and we know that section of it is 180. So from that we can say, well, this small little slice here must be 30 degrees. Okay? 210 minus the 180, that's 30 degrees. So that's step 1. Step 2, we need to determine Rx. Now in order to determine the resultant of all the x components of all the vectors, you need to sum up the x components of each. Now in order to do that, you take r times the cos of the angle it makes with the axis, and you add them all together. But now it gets a little bit tricky. You use cos if the angle is off the x-axis, like it is with the 6 Newton force that's coming off the x-axis and the 10 Newton force that's coming off the x-axis. But with this 4 Newton one, it's coming off the y-axis. So with that, we would use r sine of theta. Okay, if your angle is off the y-axis. Okay, now this sum of, that's vector addition, which means if it's going in the positive direction, you add it, negative direction, you subtract it. So with the x component, that's right versus left. Okay? So if it's going to the right, it's positive, and if it's going to the left, it's negative. Okay, so let's go ahead and do that. So for this one, Rx is equal to, okay, let's start with our 6 Newton force. So it's the value of the vector multiplied by the correct trig ratio. So it's coming off the x-axis, and I'm doing the x component, so I use cos of my angle 20 degrees. And it's positive because this is going towards the right. Okay, next one, my 4 Newton force. It's going towards the right as well, so it's positive 4, and now we pick a trig ratio. Because my angle is off the y-axis, I use sine of 10 degrees. And then my last one, this 10 Newton force, my green one, we say minus this time, because my 10 Newton force is going to the left, so it's minus 10, and now again we're going to pick cos because my angle is coming off the x-axis, so it's 10 cos of that angle 30 degrees. Okay, so we're going to type this whole doohickey into our calculator. So we've got 6 cos of 20 plus 4 sine of 10 minus 10 cos of 30, and we get negative 2,33. Okay, so negative 2,33 means that it's 2,33 newtons in the negative direction, which is left. Okay, so that's step 1. Step 2 done, we determined Rx. Step 3 is to determine Ry, which is very similar except the complete opposite. Okay, so for Ry, we take the sum of each vector multiplied by the sine of its angle if the angle is off the x-axis. And the opposite is true if the angle is off the y-axis. So we would take the sum, whoopsie, that's supposed to be sigma, sorry. The sum of each vector times its cos of its angle if the angle is off the y-axis. Okay, and here, so with x-axis, positive was to the right and negative was to the left. With the y-axis, we're looking at up and down. So positive is up and negative is down. Okay, so let's go for it. We're determining Ry, and that's going to equal. Starting again with our red one, it's going up, so it's positive, and we've got 6 times. Now we must pick the correct trig ratio. My angle is coming off the x-axis, and I'm doing the y component, so I pick sine of my 20 degrees. Next one, the blue one, that 4 Newton one. That's now going down, so I subtract 4 times. Now I'm doing the y component, and my angle is off the y-axis, so I pick cos, okay, of my angle 10 degrees. And then my last one, 10 newtons, that one's also going down, so we subtract 10, and now again my angle's off the x-axis and I'm doing the y component, so I use sine of 30 degrees. Okay, and we type all of that into our calculator, so we've got 6 sine of 20 minus 4 cos of 10 minus 10 sine of 30, and we get negative 6,89, which equals positive 6,89 newtons. Now it was negative, so that means down. Okay, so that's the first 3 steps. I'm going to actually just sort of save some space here, so I've got space to work around. Okay, step 4 is now it's a little bit easier. So step 4, you take your Ry and your Rx and you draw them in their own diagram. Okay, so our Ry is, here is it, 6,89 newtons down. And our Rx was 2,33 newtons left. So it's a tail-to-tail diagram, okay, 3-point diagram, which means we start in the same place, and now we're going left 2,33 newtons. Okay, so step 4 is you draw your resultant x and y. How am I going to put this here? Yeah. Draw our x and our y. Okay. Next up, step 5. We now have our x and our y, so we've taken our 3 vectors and changed it to 2 vectors. But we don't want 2 vectors, we want a single vector. So now from there, this is very straightforward. We can just do Pythagoras to determine the length of one vector that would have the same effect as those 2. And the way we do that is that we imagine that this is a rectangle. Your resultant vector would be the diagonal of that rectangle. So that is our resultant vector. Now remember, with a diagonal, with a rectangle, the opposite sides are equal to each other. Okay, so if this is 2,33, I can say that there is also 2,33. Okay, and it's a 90-degree triangle, so for the 5th step, we can determine the magnitude using Pythagoras. Okay, so you're doing it this way, you're going to find that the resultant squared is equal to the square of the x component plus the square of the y component. Okay, so let's go ahead and do it. We want r, so we're going to have r squared equals, my x component is 2,33, my y component is 6,89. Note I'm not including the fact that they were negative. Okay, we're looking at the magnitude of those vectors. We'll deal with the direction later. Okay. So now we solve for r. So it's 2.33 squared plus 6,89 squared, and we square root that answer and we get 7,27. So we get resultant is 7,27 newtons. Please remember to square root, eh? I'm going to make a little note to self here. Remember to square root. Okay, so we've got the magnitude sorted. Now we need to sort out the direction. Okay, so step 6, direction. In order to determine the direction, we're looking at what angle does our resultant vector make with the x-axis. Okay, so that's this here, the angle that the resultant vector makes with the x-axis. We're looking for that angle theta there. So for direction, we're going to use trig. And I don't mind if you use sine, cos, or tan, because we now know all 3 sides of our triangle. Hey, we know that's 2.33. We know this is 6.89. And we've just worked out that this is 7,27. So you can use any trig ratio. Ideally, though, use tan, because tan will use the Rx and Ry. And those were the ones that we worked out earlier on. So there's less of a chance we've made a silly error along the way. Okay. So the direction, ideally you use tan. Okay, and now remember your SOHCAHTOA, tan is opposite over adjacent. So it's going to be that one, which is the y component, over adjacent, which is the x component. So tan of theta is Ry over Rx. Okay, so we can substitute that in. Tan of theta equals, our Ry is 6,89. Our Rx is 2,33. And now remember again, note to self, remember to square root for the magnitude, and for tan, when you're working out the direction, remember to shift. Okay, we're looking for the second function. Okay, if you're looking for the angle, you need to remember to shift. So we're going shift tan, 6,89 over 2,33, and we get 71.32 degrees. Okay, so I found that theta is 71,32 degrees. Okay, so now we've basically got all the information we need, but you do need to say a little statement at the end. Okay, it has to comprise of the magnitude and the direction, and you need a little more for the direction. Okay, so we can say that our resultant vector is 7,27 newtons at, so that's our resultant magnitude, at the direction 71,32 degrees, but now that doesn't mean much. 71,32 degrees measured from where? So now is when you go back, look at your step 4 diagram. Where does this theta measure from? Well, if this is my origin over here, okay, then this angle is being measured from the negative x-axis. So there's one piece of information. But am I going that way or am I coming this way? I'm coming down, hey, which is anti-clockwise. So you need to tell me the angle, you need to tell me where it's coming from and which direction it's going. So it's 71,32 degrees anti-clockwise. And now here it's from the negative x-axis. Okay, now this is not always going to be anti-clockwise from the negative x-axis. It could be clockwise as well. This could also be positive x-axis. Okay, so you need to check your diagram, see from your diagram what is the direction. Okay, that's pretty much all there is to it. You might sometimes come into contact with questions where you've got a vector on an axis. Okay, don't panic. Then it's up to you. You can either say that that makes a 90-degree angle with the x-axis, or you can say it makes a 0-degree angle with the y-axis, and then you just pick the correct trig ratio depending on which you've decided. Okay, so you've got 2 worksheets on vectors in 2D. I can't remember if you're doing them both today, or one today, one tomorrow. I'm not sure, but you'll know that. Okay, let me know if you get stuck, please.